Hi students, welcome to YourPedia. Now I can able to examine one of the question in NPTEL assignment questions. So now I can able to take out one of the questions to you students. So this is question number 7 comes in the page number 86 now. So that you can able to examine what this question students. So find the drain voltage VD there. So you can find the drain voltage VD. This is V suffix D students. Find the drain voltage VD given mu n COX W by L equal to 0.6 milliampere per volt square. Okay, threshold voltage is 0.7 volt you can call, and ignore that channel length modulation students. Ignore that channel length modulation you call. So this is the circuit is given students. This is a NMOS transistor, right, whose source is connected to ground, gate, drain. This is 1 kilo ohm resistor, 5 volt supply call, and this is the drain supply voltage. And options is given 3 volt, 0.33 volt, 3.16 volt, and 4 volt you can call. Okay. Now you can able to examine what is this problem now. So find the drain voltage given mu n COX W by L equal to 0.6 milliampere per volt square, Vt equal to 0.7 volt, and ignore the channel length modulation you call. So little bit to discuss about that MOSFET. So this comes under biasing techniques of MOSFET transistor you can call. So in the case of MOSFET amplifier, you can find out the 3 types of biasing techniques. One is gate bias, other one is a drain bias, other one is voltage divider bias. So among that, it is nothing but a drain bias condition. Here you can able to short the drain and the gate terminals. You can short that drain and gate terminals you can call, so that gate voltage same as drain voltage you can call. So this is the gate terminal, you know. This is the source. This is the drain. Gate and drain are shorted. The corresponding MOSFET is in saturation. I think that you know that MOSFET should be considered to be operate in 2 modes. One is a linear mode, other one is saturation mode. In the linear mode, it look like to be act as a voltage variable resistor. And in the case of linear mode, what the condition you say means the drain current is function of both gate voltage and drain voltage. In the case of linear mode, the drain current is function of both gate voltage and drain voltage. Whereas in saturation mode, the MOSFET could be used as what sir means ideal current source, look like to act as a voltage amplifier, and in that saturation mode, drain current is function of only gate voltage. Drain current is a function of only gate voltage. And you know this condition for saturation is like this. What is the condition for saturation? Means VDS, that is the drain voltage, should be greater than or equal to what sir means gate over drain voltage we can call, that is VGS minus VT. Under this condition, your MOSFET is in saturation mode. VDS must be greater than or equal to what sir means VGS minus VT you can call. VDS should be greater than what? VGS minus VT you say. So VGS minus VT is nothing but what sir means overdrive gate voltage also we can call. The pinch off occurs at a particular drain voltage at which VDS equal to VGS minus VT you can call. So for VDS greater than or equal to VGS minus VT, it is in saturation region, where the drain current is a function of only gate voltage. Drain current is function of what sir? Gate voltage you can call here. In this, ID function of what sir means VGS. Drain current is a function of only VGS. What is the formula for drain current you can call sir means there, you know the formula for drain current ID equal to per NMOS, it is mu n COX. That is called what sir means a transconductance parameter, where mu n stands for mobility of electron, COX stands for mass capacitance. COX stands for what? Mass capacitance of the mass capacitor. That could be considered, right, the what sir means the capacitance considered per unit area you say. W is the channel width you can call, and L is the channel length into VGS minus Vt whole square. So this is the drain current under saturation mode, you can call. This is the formula for drain current under saturation mode. Suppose if the applied drain voltage is less than VGS minus VT, then it should be in the linear mode, where the drain current should be function of what, sir? Means both VGS and VDS, you can call. Both VGS and VDS. Now you can able to check out whether the drain voltage is greater than gate voltage or not. That you can able to examine from this circuit diagram. So it look like what, sir? Means a drain bias circuit. Now I can able to calculate the required what is that required drain voltage, right, under this condition of saturation, you say. Check up now this same circuit I redraw now. So this is the circuit diagram you given, right, sir? Just I indicate the circuit diagram now. This is of how much resistance you see now there? Sorry. So this resistance is how much, sir? Means 1 kilo ohm resistance is there. How much resistance is there? 1K is there, recall. This is 1K, right? And the corresponding supply is 5 volt is there. Right, these two are shorted. This is the thing called drain voltage Vd. So this is the circuit diagram he given, and remaining things you check out what the things is given there. Mu n COX you call, that should be called as a transconductance parameter he given. So mu n COX, so W by L is given 0.6 milliampere per volt square. That is 0.6 milliampere per volt square, sir. This is completely called transconductance parameter. That is 0.6 milliampere per volt square given. And what about that threshold voltage you check out? Threshold voltage is given 0.7 volt. Threshold voltage is given 0.7 volt there. Right? And he said that neglect the channel length modulation. What is the channel length modulation, sir? So with respect to the applied drain voltage, there is some added barrier effect near the drain. Based on that, the effective channel length should be reduced, right? By that, what you can call, sir, means in the saturation mode, you say that according to the channel length modulation, drain current not only function of VGS, little bit also on VDS. He said that neglect the channel length modulation means, so in the saturation mode, it confirmed that the drain current is only a function of VGS, not as a function of VDS. That's the meaning of it. Neglecting the channel length modulation means, so he said that in the saturation mode, no effect of VDS on the channel length we call. So the drain current is 100% a function of only VGS. Confirm? So channel length modulation is denoted by lambda, that equal to 0. So commonly it is measured in terms of the unit is volt inverse, 0 volt inverse we call. Now check up the conditions of this. What is the thing you want? So you know that this is a gate, this is source, this is a drain, this is drain resistance RD. Got it now? So it is commonly called as a drain bias circuit, where gate and drain are shorted, you can call. Among the three biasing techniques I told, one is a gate bias, other one is a drain bias, other one is a voltage divider bias we call. It is look like a drain bias circuit we call. It is a drain bias network, sir. Okay. Here the corresponding current that is passing is ID, drain current. Confirm? So this is the drain supply voltage VDD, you know. Right? So now, in our diagram, if you see, gate and drain are shorted. Gate and drain are shorted, you call. That is gate potential equal to drain potential. Vg must be equal to Vd call, or VGS gate to source voltage is the same as drain to source voltage. Got it now? So common is the source for both. Gate with respect to source is same as drain with respect to source. Then you can say that VDS must be greater than VGS minus VT, sir. Because VDS equal to VT means, sir, VDS equal to VGS means VDS must be greater than VGS minus VT. Confirm now? So just now I told that if VDS is greater than VGS minus VT, this person is in saturation mode, where the formula for drain current is like this. Right? So it is in saturation you call. It is in saturation, right? What is the formula for drain current in this saturation mode, you know just now? So ID equal to what I can call mu n cox W by 2L into VGS minus VT whole square. Now I can able to substitute that. So the formula for drain current is ID equal to mu n cox W by 2L into VGS minus VT whole square. This is the formula for drain current under saturation mode you call. Now check out now what is the mu n cox W by 2L. L is given 0.6 milliliters, that is 0.7. VT equal to how much there? VT is 0.7, sir. So mu n cox W by L is given as a 0.6 milliampere per volt square, you know. So now I substitute that. That is called transconductance parameter, 0.6 into 10 power minus 3 by 2. So VGS is unknown minus VT. VT equal to how much is given means 0.7 you call. Now 0.7 whole square, that I keep as a 1. Okay. This is the first equation I get. Now my requirement is VDS. Here in this one, I need to calculate this drain voltage, right? VD. So VD is nothing but VG you call, but nothing but VGS equal to VDS you say. And one more thing you see now, just by using Ohm's law here, what you can find out means ID equal to this potential is 5, this potential is VD, nothing but VDS by RD you can call. RD equal to how much there? 1 kilo ohm you can call. Can I go for now that? ID equal to from circuit 5 minus VD by RD you say, that is 1K. So from circuit ID equal to 5 minus VD by RD, that is 1K, right? VD is nothing but VDS you call by 1K. Nothing but you can also rewrite as VGS, because VDS same as VGS you know here, because gate and drain are shorted. So now they both are the expression for the drain current of the same circuit. This is considered from saturation condition of the circuit. This is considered from the circuit of a given specifications. So now I can equate 1 and 2 now. Equate 1 and 2 do now it do. So what you can get, sir, means 5 minus VGS by 1K equal to what I can get, sir, means 0.6 into 10 power minus 3 by 2 VGS minus 0.7 whole square. If I minimize this, I can get a quadratic equation of VGS. I can able to get what, sir? Quadratic equation of VGS. Now can I transfer this one this side? So 1K I can transfer that side. What the thing you may get? Check out. Now I can able to transfer that one that side now. So 5 minus VGS equal to, right, sir? Taking 1k that side, 10 power minus 3, 10 cube cancelled. That is 0.6 by 2 become 0.3. Now I can expand a minus b whole square equal, that is VGS square plus, so 0.7 whole square become 0.49, right sir, minus 2ab minus, this is 1.4 VGS equal, right sir. So now I rewrite this one now, 5 minus VGS square equal to 0.3 VGS square, okay, 0.3 VGS square, what you can get sir means 0.3 VGS square. Next 0.3 into 0.49 becomes around 0.123 call, okay, minus, this is 0.3 into 1.4 become minus 0.42 VGS, right sir. By expanding that one, you may get that one to be like this. So now I rearrange this. So 0.3 VGS square, okay. Next, take this one this side. So 0.3 VG, so this is not VGS square, 1 minute. Right sir. So 0.3 VGS square is there. Here what sir means, here VGS is there, here minus 0.42 VGS is there. Take this one this side, this become plus. So what you can call sir, what you can get means 1 minus 0.42 become 0.58 you can call. 0.58 VGS equate. One more is 0.58 VGS you may get. Now you can able to go for this one now. 4 minus 0.123, so take this 0.133 minus 5 you can call, that you can get around what means 4.87 something. So you may get nearly it is 4.877. Got it now? So I got a equation of quadratic of VGS. Sir, by solving this VGS, I may get root values of VGS, most probably may get negative and positive values. So, if I do this one now, one of the value of that one I may get is, if I solve this one, I may get the value of VGS should be, what sir means, one of the negative values minus 5.1. And one more to be some positive value that you may get, what sir means, some 3.17 volt you may get. So 2 values for VGS you may get. And let us see this one now. Sir, the NMOS transistor, that is nothing but operated only in enhancement mode you can call. This is the enhancement MOSFET sir, that is operated commonly in what sir means with the forward bias VGS only. So enhancement MOSFET or transistor operated with only forward bias VGS you can call. So here gate is a p-type terminal of NMOS. In the case of NMOS, source and drain are channel type of n-type, and gate is a p-type body, so that VGS must be required to operate this one in the enhancement mode. If we consider that VGS negative, that is the reverse bias gate voltage operated in depletion mode. In depletion mode, it do not have a channel. Sir, here the channel is not present physically. That channel should be created with applied forward bias gate voltage at a particular gate voltage that you can call threshold voltage. That is the minimum gate voltage you require to build the channel. So for NMOS, VGS must be made positive, not be negative. So VGS should be positive means, then which value I can take sir? 3.17. For NMOS, VGS must be what? Positive. Then VGS equal to 3.17 volt. Got it? Now you know that VGS equal to VDS, as VGS equal to VDS, then VDS also 3.17 volt. VDS is nothing but what sir? Drain voltage, drain potential VD. That is nothing but what you can call? drain potential VD, sir? That is nothing but what you can call drain potential VD, you say. So check out your question, what he asking. This is the question he asking. For a given, find the drain voltage given transconductance parameter mu n Cux W by L equal to 0.6 milliampere per volt square, Vt equal to 0.7 volt. Ignore the channel length modulation, and he given that value is nothing but 3 volt, right? 0.33 volt, 3.16 volt, and 4 volt he can call. So you calculate that value. You got what, sir? Means check up what the value you may get. So around 3.17 volt you may get. So if you go for the options, who is the nearest one means this one. So the answer go for 3.16 volt for this question. Confirm now? So he asked the question of drain voltage calculation here. So this is a drain bias circuit of NMOS transistor. So drain voltage is asking. Already you told that gate and drain are what, sir? Means shorted condition, so that the MOSFET must be in saturation mode. So I can apply the equation of current in saturation mode, and as well as here I can take out the equation of drain current ID equal to 5 minus VD by 1K. I can equate those two things. By that I got what, sir? Means quadratic equation of voltage of VGS. So once I solve that VGS, I can able to get the value around 3.16. You can call a positive. So for NMOS, gate voltage must be positive to build up the channel. That should be operating in the enhancement mode. So automatically VGS should be equal to VDS, you can call, and to calculate that one you got 3.17. So it is nearby what? 3.16 volt. So the answer for that question is what, sir? Means C. Understood now this question? Okay.